All right, so I think this is recording. Let's take a look at this equation. It's a radical equation, but yet it's different than some of the ones that we've seen previous in this homework. Instead of one radical term, we've got two. Um, so we have to get one of them by itself, and it really doesn't matter. I don't know of any rule of thumb that tells you to which of these to get by itself. So I'm simply going to add the square root of x minus 4 to each side of this equation. So on the left-hand side, I have x plus the square root of x plus 8. And on the right-hand side, I have 2 plus the square root of x minus 4. So to get rid of the radical on the left-hand side, I need to square it. So to balance the equation, I need to square the right-hand side. The left-hand side is very easy to do. The radical just goes away, but that right-hand side, you probably don't have experience in squaring a binomial that has a radical term. So some of you will be able to just jump right in and do it, and others, I would suggest doing it in the form of a table. A table is a nice, organized way to apply the distributive property. So we have this binomial times itself. So 2 times 2 is 4. And 2 times this radical is, we just write it as 2 radical x minus 4. And the same thing here in the bottom left corner. And when you square two radicals, the radical goes away. So let's return to the equation. On the left-hand side, we have x plus 8. And on the right-hand side, we need to add up the terms inside our table. Along this diagonal, we have 4 plus x minus 4. So the positive 4 and negative 4 will cancel each other out. That will not always happen. And then along this other diagonal, we are counting square roots of x minus 4. We've got 2 of them plus 2 more for a total of 4 of these square root of x minus 4. So notice that squaring the equation did not get rid of all of the radicals, but we have gone from 2 radicals in our equation to just a single radical in the equation. Now this may look familiar. This looks similar to problems that we've done in this homework, these previous problems. We need to get this square root by itself and square each side of the equation again a second time. But I notice that if I subtract x from both sides, this term and this term cancel. So now that I've got the square root by itself, I can square it, but then people might forget to square the 4. So I'm going to divide both sides by 4. 8 divided by 4 is 2. And here I just have the square root of x minus 4. So if I square the left-hand side to balance the equation, I square the right-hand side. And of course, every time I'm squaring this, I'm introducing the possibility of extraneous solutions, extra solutions that won't be solutions to the original equation. So I'm definitely going to have to check my answers for this problem. Rather than shrink that up, I'm just going to continue over here. 2 squared is equal to 4. And when I square this radical, the radical goes away, and I have x minus 4. And if I add 4 to each side, I have the x is equal to 8. Now, I need to check that in the original equation. So on the left-hand side, I have the square root of x plus 8, which means I have the square root of 8 plus 8 minus the square root of, replace this x with 8, and I have 8 minus 4. And the big question is, will that arithmetic result in 2? Well, 8 plus 8 is 16, and the principal square root of 16 is 4. And 8 minus 4 is 4, and the principal square root of 4 is 2. And 4 minus 2 does equal 2. So yes, this is in my solution set, and that's my final answer for this problem number 11. So like I say, when there's 2 radicals in there, you're going to have to isolate one of the radicals, square each side. When you square a term that has a radical, so that you don't get yourself confused, I would do it in the form of a table. You don't have to do that, That's just my suggestion. Hope that helps, and I will talk to you later. Bye.